Okay, we're back again for more lecture 31. Okay, these problems, I've got e to the y plus 5 divided by 2 power equals x to the 5th minus 3x plus 5. What the heck? That looks crazy. It is. Okay, I'm going to be honest with you guys when you're trying to solve these. It's going to get weird. Okay, your answers are going to look crazy. Don't freak out about it. You're solving these equations for one variable. You're solving it for y. Okay? Our only goal with this is to get y by itself. It does not matter how crazy everything else is going to look. Okay? So, starting out, my first concern up here is the fact that this y is up in the exponent. So I have to get it down from the exponent. How are we going to do that? Well, we're going to have to hit it with a log. Since it's an e, that means we're going to need to hit that with a natural log. And if I do that to one side, I'm going to have to do it to the other as well. Okay, on my left here, my e's gone. That's good. I've now got y plus 5 over 2 equals ln of x to the 5th minus 3x plus 5. So how do I simplify that on the right, Mr. Schubert? You don't. Just leave it. Okay, you're not going to do any simplifying on this. The only thing we're trying to do is we're trying to get y by itself. Okay, so my next step then in trying to get y by itself is, I've got this 2 at the bottom. Let's multiply by 2 to get rid of it. So I'm going to multiply this side over here by 2. 2's cancel. I get y plus 5 equals, I'm going to write the 2 out in front, because normally that's where we see it written when we deal with our natural logs, or our regular logs even. Okay, but what do I need to do to simplify on the right? Nothing. We're not simplifying on the right. Okay, stop freaking out about it. Last step, I've got to get y by itself. It's got this plus 5 here. I need to subtract by 5 on both sides. Okay, that's going to cancel, and I get y equals 2 times ln of x to the 5th minus 3x plus 5 minus 5. And that crazy thing is your final answer. Okay? You cannot subtract the 5 with this plus 5 down here because that plus 5 is in the logarithm. Okay? But, I'm not kidding you guys. That is your answer. Okay? Looks weird. I know it. But we got y by itself. That was our main goal. Okay? You're going to have a couple problems like this on your homework for you guys to practice. So hopefully when you get to your test, you're not going to be freaking out as bad. Okay? Let's do another example then. This time I've got log base 3 of 3y plus 2 equals x squared plus 1. Okay, so this time my y, first thing I notice is it's inside a logarithm, so I need to get rid of that. I'm going to need to exponentiate. And the base, when I exponentiate, is going to need to be 3. So I'm going to raise this to the exponent, and I'm going to raise this over here to the exponent. These will cancel. So now I've got 3y plus 2 equals 3 to the x squared plus 1 power. Do I need to simplify on the right side? No, don't worry about it. Okay, we're just trying to get y by itself. Next step, to get y by itself, subtract 2. Okay, gives me 3y equals 3 to the x squared plus 1 minus 2. Do I need to simplify on the right? Don't simplify on the right. It's fine. We're just solving for y. Okay? Getting y by itself, last step. Divide by 3. Divide everything by 3. That gives me my final answer, which is y equals 3 to the x squared plus 1 power minus 2, all divided by 3. Should I try and cancel something to simplify on the right side? No, leave the right side alone. That right there is your final answer. Okay? Looks weird. I know, okay? But that's what they're going to have you guys do on your test. It just specifically says to solve for y. It does not say anything about simplifying, so don't try and simplify these problems, okay? Hopefully that goes well. We're ready for our last set of problems. Our last set of problems involve real-life exponential equations. First two that we're going to talk about are interest. You have your interest compounded at certain intervals, okay? Interest compounded at certain intervals. Here is your equation, okay? I'm not going to say that you need to memorize that, but you may have to. So I'll tell you when I get back. Your A is going to be the amount after a certain time. Your P is your principal statement. Essentially, your P is where you're starting. Your A is where you're finishing at. Okay. Your R represents your interest rate. Your N is how many times it's compounded per year. So your N, and you may want to write these down. Your N, it could say that it's compounded annually. Okay. Compounded annually, it's compounded once a year. So my N value is 1. It's compounded semi-annually. That means it's compounded twice a year. So your N would be 2. If it was compounded quarterly, that would be 4 times a year. So your N would be 4. Compounded monthly, 12 times a year. Your N would be 12. I think you guys get the point at this point. Oh, I said point a lot. Then you have your T is your last variable. Okay. That T is just how many years it's being compounded. Okay. So if you're reading the problem, it says something about it being compounded semi-annually, compounded quarterly, compounded monthly, something along those lines. This is the formula that you have to use. There is another option, and that other option is if your interest is compounded continuously. So the formula, if it's compounded continuously, is A equals P times E to the RT power. Okay, again, your A is basically your finishing amount. Your P is where you're starting at. Your R is still your interest rate, and your T is your years. Remember that E is not a variable. Okay, we've talked about this in the previous lectures. That E is not a variable. That E is like pi. Okay, it represents about 2.71. You've got a button on your calculator for it. Okay, so there's nothing to plug in for that E value there. All right, let's go ahead and solve some of these. So suppose we've got $4,000 and it's deposited in an account. How much money will be in the account after 7 years if the interest is compounded monthly? Okay, it's compounded monthly. We're going to have to use the more complex one, okay, the one that does not involve E, right, at a rate of 2.75. So let's start figuring out variables from as we're reading through this. My P is 4,000. That's what I started with. My N is going to be 12. It's compounded monthly. Okay. My T is 7. It's been in the account for 7 years. And my interest rate is 0.0275. Remember, you've got to turn your percentage into a decimal. So it's 0.0275 for your interest rate. Now, we're wanting to know how much money will be in the account after 7 years. So we're looking for that finishing amount. That means that we're looking for A. Okay? So there's my original equation. I just need to plug all these values that we found in here, plug them into this equation. So starting out, I've got A equals. We don't know what A is. But it equals 4,000 times 1 plus my interest rate, which my interest rate is 0.0275, over how many times it's compounded in a year, which would be 12, to the N times T power. Okay, now, when you guys do this, take the time. If you need to pause this video, but take the time to plug this in your calculator and make sure you know how to plug it in. If I was you guys, the first thing I would do is I would simplify what's inside my parentheses here. Don't hide any decimals, okay? Write all the decimals out. But simplify inside here, and I'd go ahead and take 12 times 7. And if you do that, you should get 4,000 times 1.002291667 to the 84th power. Write out all these decimals. It's going to help handle any rounding errors that you guys will find, okay? Once you simplify it down to that point, then plug that in your calculator, and you should get your final answer. Okay, 4,848.04. Plug that in your calculator and make sure you're getting the answer. If you need to, pause the video. Okay, we're going to go ahead and go on. Look at another problem. This one says, suppose $4,000 is deposited in an account. How much money will be in the account after 7 years if the interest is compounded continuously? Compounded continuously. Okay, that there tells us we're going to need to use the formula that involves E. So I'm still going to have my P as 4,000. I'm still going to have my T. It's still in there for 7 years. And my interest rate is still the same. But the formula that I use is going to have to be A equals P times E to the RT power. Okay? I know I use that formula because it's compounded continuously. So I'm going to plug in my information. 4,000 for my P. I'm going to take 0.0275 times 7. That is up in the exponent. Honestly, this one's probably simple enough. You can plug it all in at once. If you wanted to try and simplify it, plug in just your exponent to start. Okay? Plug that in. Should get about 0.1925. Okay? And then plug this in your calculator. And you should get 4,849.11 for your answer. Again, if you need to, pause the video, take your time on this, make sure that you get the correct answer. Okay? We're going to go ahead and go on. Okay? Last type of problem you guys can see. This is more of a word type problem. It says the function a equals a naught times e to the negative 0.00866x models the amount in pounds of a particular radioactive material stored in a concrete vault. X is the number of years since the material was put in the vault. If 200 pounds of the material are placed in the vault, how much time will need to pass for only 59 pounds to remain? Okay. Whoa. Sounds like a lot, but we can handle it, I promise. I've got A naught. Okay, remember, your A naught, anytime there's a 0 down there in the subscript, that means it's your starting value. So that's our initial amount. Just the A is after the amount that's left after a certain number of years, and X is our years. Okay, so if I'm reading out 200 pounds started, 59 pounds finishes. Okay, so the only variable I have left is my X. So I'm going to have 59 equals 200 times e to the negative 0.00866x power. So I'm trying to solve for x. Where is that x at? Well, that x is up in the exponent. I'm going to have to hit this with a log at some point. Okay? Now, I'm going to have to hit it with a natural log because we've got an e as our base. But before I can do that, I've got to get rid of this 200 that's sitting over here. So my first step is going to be to divide both sides by 200. So I've got 59 over 200 equals e to the negative blah, 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 blah. Okay? Then, now that I've got just this e there, I can hit this with a natural log. Okay? And if I hit this side with a natural log here, that ln and that e will cancel each other out. So I've got an ln of 59 over 200 equals negative 0. Blah, 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 blah. Okay? So I've just got the negative blah, blah, blah times x. So the only thing left that I need to do is I need to divide both sides by this decimal here. Okay? Got to divide both sides by that decimal. And when I do that, I end up with this big crazy fraction. Okay? That big crazy fraction will not be your answer. Okay? But I would wait, and I would caution you guys just for rounding errors. I would wait to simplify anything until you get to this fraction here. Okay? Then you can work your way down through 59 divided by 200 equals ln of my answer, and then take your answer divided by this negative decimal down here. When you do that, you should have 140.97 years. Again, take your time, make sure you plug that in and get your answer right in your calculator. Okay? I've got the answer key hanging up on the board over there for you guys. Your homework is going to be the homework packet, lecture 31. Good luck, and I will see you guys back on Tuesday.